go from this place here. All right, a couple things before we get started on the actual trig. I just wanted to mention this a few times before, but just to go over with you now so you'll know. My office hours today are modified somewhat. Usually I'm in the office after this class from 10:45 until 12:30. Okay. Starting, today, I've got to go to the Birmingham campus shortly after 10:45 to pick up the van, bring it back here so I can take my class on the field trip this afternoon in physical science. So that means that I won't be in the office much. I'll go down there and just get my jacket and stuff at 10:45, drive over to Birmingham. That takes about half an hour. Got to get the van, check it out and stuff. Hopefully that won't take too long. Drive back here, so it's going to be another half hour. So I'm guessing at the earliest, 11:45 to 12 o'clock, sometime in there, I'll be back in the office, and then I'll only be there for 30 minutes. Okay, so very short office hours today. But on the positive side, we go to the field trip. That's basically 2 to 3. It takes about 45 minutes to get back here, so that's 3:45 or so, maybe 4 o'clock before we get back here. And then I'll be giving a final exam for that class, which isn't going to take long. It's a very short and easy final, so it's a mini-term class. So once that's over, I should be back in the office 4:30, 4:15, 4:30, something like that.
I'll leave at 12 anyways.
Okay. So, well, I'm doing this on here for anyone else who's looking to. Okay, so that's my adjusted office hours for today. Tomorrow, unfortunately, I have a doctor's appointment at 8 o'clock in the morning. So I won't be on the Birmingham campus at 7:45. I'll be at Kirkland Clinic at 7:45, not holding office hours. And the physical, hopefully, will be through by 9, meaning hopefully I'll be back on Birmingham campus by 9:45 or 10. If everything goes well, there's no delays or anything like that. So that's the deal there. I'll be there probably after 10, hopefully by 10, and until 1 o'clock. Okay? So that's tomorrow. All right, beginning next week. 2 things happening next week that you need to know about. This is the end of the first mini-term this week, and next week, second mini-term begins. I mean, sometime over the weekend is midterm, okay? Don't know exactly when, but sometime is midterm. Next week, they have on the academic calendar, and they always put it there, but sometimes forget about it. They have on their midterm progress reports due, okay? Now, sometimes they forget to open them, okay? Whatever. Now, I know you're not in any kind of, well, let me see.
I finished it, and I was like, I'm going to bring it today, because he said something at the midterm, I was going to bring it today, and I completely forgot about it all the time.
Okay.
So if I turn it in Tuesday, will it be okay?
That's fine.
Okay.
Just sometime next week, I'd like to have a score from everybody. So far in this class, only one person has done a paper, and 1, 2, 3, 4, 5 have done the first test. So that means that 9 haven't done papers and 5 haven't turned in the first test. So if you can get them back to me sometime next week, okay, either the paper or the test or both, that would be great. That would be fantastic. So I will have a grade for you. Otherwise, if they ask for midterm progress report and I don't have a score, I have to put it down that you're failing at midterm, which doesn't really matter to anything except someone will be contacting you to see what you need to do. Huh? I don't eat it, catch you. That what?
A lemon cream filled.
Well, you're probably on it later.
Good. I'm going to eat lunch as well.
Huh?
Pretty good.
Oh, okay. Yeah, they sound like it. Let's see if anyone else wants to take on that. Or you want me to have my mouth full, so I'll shut up. Okay. They are good. Now, that was the first of the announcements for next week, is that midterm progress reports may be asked for. If so, I have to report something. So get something to me by next week. Second new thing about next week is my office hours change on Tuesday and Thursday. Right now, Tuesdays and Thursdays are 10:45 to 12:30. beginning Tuesday, they'll be 10:45 to 1:15. So a little bit bigger window of office hours on Tuesday and Thursday. Monday, Wednesday stays the same. Friday stays the same. Tuesday and Thursday expand. Okay. Any questions on anything trigger related or otherwise? Okay. Where we left off last time was Chapter 4, Section 4.7, and we were doing other trigonometric, inverse trigonometric functions. What's the other for? What have we done already? Second? Besides the other trigonometric, what have we done that they put other up here? The only one that we did in inverse for. Okay, how many trig functions do we have? 6. Which one have we done a trig function, inverse trig function for? Huh? Sine. Paying a lot of attention. Okay, sine. Okay, we did sine. Now we're going to do the others. 4.7, page 322, top of the page. Okay? Now, the cosine function is the one we're going to do now. Now, remember what the deal is with inverse functions. What does a function have to be to have an inverse? One-to-one function. All right. Earth to Tyler, come in, please. Okay. Now, okay, you have to be a one-to-one function. In general, is the cosine function a one-to-one function? What test does it have to pass to be a one-to-one function? Horizontal line test. Does the cosine function generally pass the horizontal line test? No. Look at it. It does this all over and over. So any horizontal line is going to intercept an infinite number of times. So what must we do then? Restrict our domain to a one-to-one segment. Okay. For sine, that went from minus pi halves to pi halves. That won't work for cosine, will it? Fails the horizontal line test there. So pick a segment of the domain that it is one-to-one. The easiest is 0 to pi. Okay? Now, in that segment, cosine is decreasing. That's what they say. And one-to-one there. So we can define an inverse function, but only on that domain. Which means, of course, what would this be to the inverse function? What does an inverse function do? It's not reciprocal. It's inverse. But still, it exchanges the domain for range. So since this is the domain of cosine for which it's one-to-one, this would also be the range for its inverse. So the inverse function must go from 0 to pi on it as a range. Okay? Now, what's the range of cosine x from here to here? Minus 1 to 1, right? I forgot to turn on light. Maybe that's why you're not too bright. I mean, no.
This confuses me.
Pardon me?
This confuses me.
Okay. Okay. Frankly, I think that's what's hindering you the most. Yeah. Okay. So what's the range of cosine x? Negative 1 to 1, exactly. So that becomes a what for the inverse function? It changes this is the range here. It'll be the domain for the inverse function. So that'll go from minus 1 to 1 with the range going from 0 to pi for the inverse function. We aren't there yet, but we'll get there. So cosine x has an inverse on that interval. Nothing beyond here or here. Now, you could have chosen another interval, but we usually don't. That's the most convenient to use, so that's what we usually use. Okay, so consequently, on that interval, the cosine function has an inverse function, the inverse cosine function, and Kamari, I think I remember what he looks like. Yeah, I believe that's him. Okay, I'm picking on everybody who that here, right? And Mardi Gras was Tuesday. Yeah, never mind. I'm just kidding. Okay. All right. Did you finish?
I'm done. The ones that I didn't do, I can figure them out.
Okay, you are finished. Okay. You finished? Good deal. Okay, I hope so. All right. Good deal. Okay. All right. So the inverse cosine function is written one of two ways, either arc cosine or inverse cosine. Means the same thing. Okay? Inverse cosine function. Now, let's talk about what it actually is. Similarly, you can define, that's all they did for cosine? Hard to believe. Okay. Similarly, you can define an inverse tangent function. Now, what's the usual domain for a tangent function? Yeah. Maybe help you think what is tangent function in terms of its identity. A quotient identity, a ratio identity. What is it?
Like what it is?
Yeah, that'll do.
Opposite over adjacent.
Opposite over adjacent, very good. And adjacent, being in the denominator, could not be, it could be negative, no problem. Or can you never divide by? Zero, it can't be zero. Where is the adjacent equal to zero? Adjacent, by the way, if you did the opposite with your y value, adjacent is the x value. Where is the adjacent equal to zero? So on the unit circle, it starts here, certainly not zero there. As it moves around. Yeah, anywhere coming on the y-axis. What are your values on the y-axis that make the x equal zero? So that is here. Okay. Where is tangent? The adjacent side for tangent, which is tangent is opposite over adjacent. Where is the adjacent side, which is x value, equal to zero? What values for theta? Again? Yeah. No, where the x value is zero, that would be on the y-axis. And where is that? What angles are those? Say again?
What angles are they?
Yeah. That puts you on the unit circle. Okay. When are you up here? When are you down here? Those are the only two places that the x is zero. Say that again? 2 pi is over here. Huh? Pi half, yeah, your half pi. Your half pi is your zero. So therefore your tangent function is not defined at the half pi, any of the half pi's. So, but it's defined everywhere in between the half pi's. Is that 1 to 1 there? Or what would you have to do? Restrict the domain. To what? Okay, not negative 1 to 1. Negative pi halves to pi halves. That's 3.5 pi, right? But it can't be this one or that one because it's not even defined there. So negative pi halves is less than x, and x is less than pi halves. Not less than or equal to, less than. So that's the domain over which the tangent is 1 to 1. Now, each of the others it is too, but that's the most convenient one. Negative pi half to pi half. What does that define for you then? You finished? Good deal. Thanks. What does that define for you? If that's the domain of tangent x that you're interested in, what does that define for you for the inverse tangent? The range. So it's going to go from negative pi half to pi half, but not either of those values. Just up to them, but not that. Okay? So the domain restricting the domain of y is equal to tangent x to minus pi half to pi half will then, in effect, restrict the range of the inverse tangent to negative pi half to pi half. So the following list summarizes the definitions of your three most common inverse trigonometric functions. We usually don't do inverse cotangent. Thank you very much. And what's even nicer, we don't do inverse secants or cosecants. Thank you very much. Because if you think about secant and cosecant, they look like this. And you have to have half of that and half of that, and they're not even connected. Nowhere close to being connected. So thank you for not doing inverse secants or cotangent secants. And inverse tangent, cotangent secant. So here's your definition for the three inverse trigonometric functions we most often do, which, by the way, are the three that are on your calculator. By the way, okay? So your arc sine or inverse sine, y is equal to that, if and only if sine of y is equal to x. See, the arc sine undoes sine, sine undoes arc sine. They're inverse functions of each other. Okay? So, for the arc sine, what is your domain? Negative 1 to 1. You read through my hand, right? Okay. Did you finish? Yes? Okay, you wrote not finished, so leave it there.
Oh, no.
If you want to come back, you can.
Finished.
Okay.
Okay, that's fine.
Yeah. Okay. Okay. All right. What's the range of your inverse sine? Say that again.
Negative pi half to pi half.
Yeah, for sine, that's absolutely correct. What's your range for arc cosine? I mean, your domain for arc cosine? Don't look so pagan. Domain for arc cosine. Hey, guess what? It's the same as the range for cosine. What's the range for cosine?
0 to pi.
Okay. We talked about the domain for cosine. What's the range for cosine? What's the range for sine?
Negative 1 to 1.
All right, cosine looks just like it, doesn't it? It just starts at a different place. Negative 1 to 1. So if that's the range for cosine, that's the domain for inverse cosine or arc cosine, right? What would then be the range for arc cosine?
0 to pi.
0 to pi. Fantastic. How about arc tangent? What's its domain?
Negative infinity to infinity.
All right. Why is that? Because that's the range for your tangent function. Tangent function starts here and goes up, right? Goes from negative infinity to infinity, therefore that's the domain for the inverse tangent, or arc tangent. Okay, what's the range for arc tangent?
Negative pi half to pi half.
Same as for sine? No. Why not?
That's what the book says.
No, it doesn't. Look carefully.
Oh, it's not. It's less than.
Ah, yes. You don't include the half pies. You include the half pies for sine. You don't include the half pies for tangent because it's not defined on the half pies.
How would you say that?
Huh?
How would you say it then? Because for the range for arc sine is negative half pi to half pi.
saying it like that in words, non-inclusive. Don't include the ed influence. Where sign would be inclusive, including the influence. Okay. Usually you say less than or equal to or less than. You include the equal or not include the equal. And that's what they've done here. So you got here, less than or equal to, just strictly less than. Okay. Good deal. Why did they do strictly less than here? Yeah, it's infinity. It's not a number. Okay. In infinity, there is no equal to infinity. Okay, right. That was a trick question. And you got it. Okay. That done. Here's what the arc sine, inverse sine function looks like. It goes from -1 to 1, like you just said. Input. Output goes from negative pi halves to pi halves. Inclusive. So, and whereas the sine function, if you drew the sine function on here, it would be like this, with a horizontal slope at the ends. These have almost vertical slopes at the end. That's how I remember to do that. In the middle, they look the same. It's almost a 1-to-1, and that's where you're reflecting across. Now, arc cosine to me is harder to get right. What you have to do is think. The cosine goes from 0 to pi. So therefore, the range here has to go from 0 to pi. The cosine starts at 1 and goes to -1 in that thing. And because you're flipping those, it's at pi at -1, you have to put the -1 pi, +1, 0, and then connect it like this. Again, with near vertical slopes there. To me, that's the hardest one to think of how to grasp. And you snuck in. Thought I would miss you, huh? I got you. Okay. All right. And by the way, I did say this earlier, and I guess I'll say it every time someone comes in, even Amber. I was going to try to get it done before she got here, but I didn't. Since we got half the class here, just wanted to remind people of this. This is the end of the first mini-term this week. Next week starts the second mini-term. Okay, so what? Well, that means midterm was somewhere this weekend, right? Okay. Now, the first week of the second mini-term, that's next week, on the academic calendar, they have listed there midterm progress reports due sometime between Monday and Friday. Now, quite often they don't even open them up for us. But if they do, I have to report anyone who has a D or an F at midterm. And guess what that means? If I don't have a paper, some sort of grade, that's an F at midterm. Not that it matters that much, but then someone may be contacting you, see if you need tutoring, see if you need counseling. So if you want to avoid all that mess, and I want to avoid it, then get me something. Half of you, I'm not saying half of the ones that are here, most of you who are here have turned in something, but some of you haven't, okay? I've only had one paper turned in, and I've had half the test turned in, but not the same half of the students that are here. Most of you have turned in the first test. So I'm also saying this for people listening. I need something in, either your paper or your test, preferably both, sometime next week, okay? If you haven't turned something in, I need something to be turned in before the end of the week next week, because otherwise, if they ask for it, I have to write, nope, got an F at midterm. Don't do that. Okay. All right. This is what your three inverse. Oh yeah, we got this. We did get this one. The tangent function. Tangent function goes between minus pi halves and pi halves like this. This is the positive, negative infinity for range. So when you do the inverse tangent, the domain is negative infinity to positive infinity. The range is negative pi halves to pi halves. Non-inclusive, because it never touches either of those. Because it couldn't touch the vertical asymptote, it can't touch the horizontal asymptote. Make sense? All right, I think we're ready for example 3. 3 parts to example 3. Find the exact value of the arc cosine of square root of 2 over 2. Okay? Here's how I do this. And you don't have to do it this way. I go on and assign some value to that, some variable to that. What variable would you like to assign that to? Second? A. Does this equal A? Okay? Now I want you to rewrite that equation in an equivalent equation. Rewrite this equation as an equivalent equation. It's pretty easy. This is an inverse cosine. Okay, how would it go? Cosine of? No, cosine of this side, A, is equal to this, the square root of 2 over 2. Now I ask you the question, what angle A, nice name for it, has a cosine of square root of 2 over 2? By the way, you always answer these in radians, unless somehow it says do it in degrees, generally in radians. What angle A in radians would have a cosine of square root of 2 over 2? Say again? Get to know these. These are your standbys. These are the ones we always use a lot. What angle A has a cosine of square root of 2 over 2? Pi fourths, exactly. Now the next question is that in the domain or range? Domain is the range of arc cosine or inverse cosine or the domain of cosine, either one. Of course it's in the domain of cosine, but it's in the part of the domain that we define for the inverse function. Yay or nay? Yes, it is. Absolutely. All right, how about arctangent of 0? Want to assign a variable to that? Second? Second? C? B. Okay, we'll use B for B. Okay, I remember now. So rewrite this equation. Tangent of a B is equal to 0. And I think Tyler already answered it. What would B have to be? Of course B would have to be B. Okay, no, 0. Okay, and is that in the domain of tangent and in the range of inverse tangent? Yes. It's centered on 0. Okay, that one's pretty easy. How about this next one?
Q.
Second?
Q.
Q. Okay. All right. Just breaking the mold, right? And here is Jasmine. Okay, I've said it for the others. I'll say it again. Actually, there's a couple things. I didn't go and say them all. My office hours today are limited because I've got to go to the Birmingham campus, pick up a vehicle for my physical science class, and come back. So I probably won't. I'll be in the office right at 10:45 or as soon as this class is out. But I'll be leaving to go to Birmingham campus as soon as I can. I hope to be back before 12. No guarantee, but then I'll only be in the office 12 to 12:30, okay, or thereabouts. But on the good news side, my physical science class, this is the last day. We're going on a field trip, and they're going to come back and take the final. So that means I should be back in my office sometime between around 4:15 or so. Maybe a little later, but so I will have office hours at the end of the day, but I do have to leave by 5:15 this evening. A lot of days I stay late, not today. All right, tomorrow my office hours are also changed because I've got a doctor's appointment first thing in the morning, so I won't be on the Birmingham campus until around 10, hopefully before 10, but 10 to 1 approximately, okay? Next week, my office hours change because my second mini-term class starts at a different time from first mini-term. So on Tuesdays and Thursdays, my office hours will start at 10:45 when this class is over with and go until 1:15 because the second mini-term class starts 45 minutes later than the first minute class did. So I'll have a little bit bigger window for office hours on Tuesday and Thursday. And then finally, and this is what I was actually going to tell you, is that sometimes they do ask for ask for midterm progress reports the first week of second mini-term. It's on the academic calendar, but sometimes they don't open them up. So if they do ask for it, I have to report anyone who is failing at midterm, which of course in this class would mean you haven't turned anything in at midterm. So most of you have turned in something, but not everybody. So get me something by next week, sometime next week. All right, so let's rewrite this equation. Inverse tangent of -1 is equal to q. What would that be? New equation, equivalent equation. Help me. Tangent of q is equal to -1. What value q would make that statement true? Negative what? You got it. Negative pi fourths. Q is equal to negative pi fourths. And why? Because the tangent of negative pi fourths is -1, and therefore the inverse tangent of -1 would be negative pi fourths. Perfect. That's in the domain of tangent and in the range of inverse tangent. Good deal. And that's what they got in the book, which may be where people, not that anyone would have been looking there. Okay? Now, let's move on. Okay. Let's see how they did it first. Okay? And I think they do it what to me is really squirrely. They say, because this answer is true, therefore that's the answer. Which to me doesn't really make a lot of sense. Okay? But that's how they do it. It's sort of the same thing we're saying. What I said was set that to be a value, a variable, and cosine of that variable has to be this. What makes that true? That variable to be pi fourths. Okay? And it's in the domain, okay, of the inverse tangent function. Okay? So arc cosine of square root of 2 is pi fourths. Okay? Now, also remember this. To me, this is helpful. When you have a trig function, what's the argument of the trig function is always an angle. Most of the time in radians, but it could be in degrees. And what's out here is some number. For cosine, it's between -1 and 1. So when you're doing an inverse, what has to be the argument here is the number. What's the answer has got to be the angle. So you expect to find an angle type answer for an inverse trig function. Okay. The second one, exactly what we did, because tangent 0 is 0, 0 lies in the domain of the inverse tangent. It follows that the arc tangent of 0 is 0. Again, they start with the answer and then make it seem like, oh, and because this is the answer, it's the answer, which to me is sort of circular in process. And the same thing here, but if you assign the value to it, the tangent of what angle is equal to -1, that angle has to be negative pi fourths. And it's in the domain of the inverse tangent minus pi fourths. I'm sorry. In the domain of tangent, which is in the range of inverse tangent, negative pi fourths, half to pi half. Good deal. Any questions on those? Pretty straightforward. Now, okay. They're skipping example 4. So let's us do example 4. All right. Oh, and by the way, there are checkpoints after every example, so please do the checkpoints. Okay. Example 4. Use a calculator to approximate the value, if possible, of arc tangent of negative 8.45. Okay? What would be an approximate value for arctangent of negative 8.45? First, is that even doable? What is the domain of the inverse tangent? Anyone remember? What's the domain of inverse tangent? Hint, it would be the range of tangent. Earth to class, come in please. Okay. Not quite on here. It would have been on the next slide if I had left that up there. What is the domain of inverse tangent? In other words, what's the range of tangent? Hey folks, you gotta get pretty familiar with these things, or else they'll sneak up and bite you.
You said what's the domain of tangent?
Domain of inverse tangent, or the range of tangent. Same answers.
Is it negative pi, half,
Okay,
pi?
that's the range of inverse tangent. What's the domain of inverse tangent? Negative infinity to positive infinity. Sure enough, that fits. Okay, it's in between. It's a real number. All right. Okay. So with say again. Okay, what mode are you in? Okay. See what you're calculating. What mode are you in? Yeah, I believe it is too. But you need to always be sure you're in the right mode. What's that? Okay. So what did you say the approximate answer was?
Negative 1.45300.
That's fine. Okay. About that. Okay. Let me get Elijah here. EJ here. Sorry about that. EJ here. And I guess I need to say it one more time. Just minor things at first. Office hours today are somewhat modified because I've got to go to the Birmingham campus shortly after this class is over with to go pick up a vehicle for my next class. We're going on a field trip. So basically my office hours are going to be about 12 to 12:30 and that's it. Whereas normally 10:45 to 12:30, okay, today. But that next class is their last class. After we go on the field trip, we'll come back, they'll take the final exam. It won't take them that long, so I'm guessing I'll be back in my office sometime after 4, okay? So you'll pick up some office hours then. They aren't official, but I will be in the office from 4 to about 5:15. I've got to leave at 5:15 today because we're going somewhere this evening and I got to get home, okay? So tomorrow's office hours will also change. I've got a doctor's appointment in the morning at 8, so I won't be in the office until around 10 or so. Hopefully before 10, I'll be there 10 to 1 approximately. Okay? Next week, because this is the end of the first mini-term, next week is the beginning of the second mini-term, they sometimes open, it's on the academic calendar, that midterm progress reports are due next week. Sometimes they don't open them up for us, so we don't do them. But if they do open them up, I have to report anyone who is not passing at midterm. D or F at midterm, okay? Who has a D or an F at midterm. And I was saying before, half of the class is turned in the first test and only one person is turned in the paper. I've got to have a score for you or else I have to turn in an F, okay? So please get me something. If you haven't turned in either the paper or the first test, get it to me next week. Get it done this weekend so you can get it to me next week. All right, so there was inverse tangent of negative 8.45. Oh, one other small change. Office hours beginning next week on Tuesday and Thursday, they have been 10:45 till 12:30. From next week on, they'll be 10:45 to 1:15 because my second mini-term class starts later than my first mini-term. Okay, you had a question to that?
My calculator keeps giving me an error when I try to put it in.
Okay, are you in radian mode?
Yeah.
And you're doing inverse tangent or tangent?
Shifting.
Okay, let me just see your calculator. That sounds right. Now do negative 185, 8.45. Okay, now the negative key that you use. Oh man, what do you use as a negative key? That's the subtraction key most of the time. That's what my guess is. Just got to find the key that your calculator uses for that. Usually it's down here. Ah, there it is. It's that key. See, this is a subtraction key. So can you go back? Yeah, you enter that key for it. Okay, now it should go. Okay. All right. I think I covered all the announcements. Let's move on. All right. Let's do inverse sine of 0.2447. Now, first answer me this question. Can you even do that? What is the domain of inverse sine? Anybody? What's the domain of inverse sine? Negative 1 to 1, so this certainly fits. Okay? All right? What is the approximate value? And by the way, let's back up to inverse tangent. If you remember how the graph looks, it looks like this. So for negative inputs, you expect to have a negative output. Sure enough, we did. For this one, for sine, if you remember how it looks, it does something like this. So a negative input would be a negative output. Positive input would be a positive output. You expect to have a positive answer, do you? Inverse sine of 0.2447. .247. Okay, very good. Now, I also meant to ask this question. Let me back up to inverse tangent. Is this in the range of inverse tangent? This one? What is the range of inverse tangent? That's the domain of inverse tangent. Negative pi halves to pi halves. And what is negative pi halves approximately? Pi is about 3.14, right? And half of that would be about 1.57. And this is within that. Negative, barely in that, but it is in that. Okay? How about this one? The domain of inverse sine, you said, was negative 1 to 1. What's the range of inverse sine? Negative pi halves to pi halves, and that's certainly within that. Huh?
It's not like equal to.
Okay, now here, I don't know if this is what you, okay. Oh, yeah. For inverse tangent, you don't equal the negative pi halves to pi halves. Inverse sine, you do. But, I mean, that's just right at the edge. Okay. Now, here's something to note. For small angles, and we're talking about radian angles, small radian angles, notice how close the sine value is. Isn't that interesting? You know why that's true? Look at your inverse sine function. That's almost 1 to 1. So you go a small distance here, you're almost the same. That's almost the y equal x line right there. And the small angles here, that's almost the same. The closer you get to plus or minus 1, the more you deviate from that. But for small angles, that's very good. Later in physics, you'll use that property when you're talking about pendula and things like that. Okay. Now let's do the last one. Arc cosine of 2. Anyone get an answer for that one? Arc cosine of 2.
Give me an error.
Well, then do it right.
I did do it right.
The answer is you can't do it. Okay. All right. Why? Why can't you do it?
It's not within the thing.
Domain, you're absolutely right. The domain for arc cosine is
Negative 1 to 1.
-1 to 1. That's outside. So this is, what do they say? What do the answer do they give?
It says
Error message.
The calculator should display an error message because the domain of the inverse cosine function is
Okay. What I would say is does not exist or impossible or something like that because you can't do it. You're absolutely right. Okay. There are some checkpoints there. I would definitely do those. All right. Let's move on then. Let's move to the compositions of functions. Y'all remember this from before, right? Yes. Okay. We know, for those who had Math 112, some of you, I know you were sitting in a class in Math 112 anyway, okay? We know that for all x's in the domains of f and f inverse, the inverse functions have the properties that if you take the function of the inverse, you always get what you started with, at x. If you take the inverse of a function at x, you always get what you started with, x. That is the principles of inverse functions. Now, of course, your x has to be within the domain of f inverse for this to work, and it has to be within the domain of f for that to work. But as long as it's in those domains, then that's what you get. Otherwise, it's not an inverse function. If it doesn't give you that, it's not an inverse. So the same thing is true of these inverse trig functions. So if the x is in between -1 and 1, that's the domain of what? What two inverse trig functions? -1 and 1. Sine or cosine, yeah. And your output, the range is from -pi halves to pi halves, inclusive. What would that one be? Sine and sine only, okay? Why wouldn't it be tangent? Yes, it's not equal because tangent is not defined at those values, okay? So, as long as this is true, the sine of an arc sine of x has got to be x, because this is an inverse sine of x. And the arc sine of y in this range has got to be y. Okay? Now, if you had the same domain here, values for x, but these values for y, what do those correspond to? 0 less than or equal to y less than or equal to pi. What function must you be, inverse function must you be talking about? Cosine, and cosine only, because cosine is only defined to be 1 to 1 from 0 to pi. So therefore, inverse cosine can only have those as input, output values. Okay? Then the cosine of arc cosine of x is x, and the arc cosine of cosine y is y. Now, if x is any real number, what inverse function must you be talking about? Tangent function, inverse tangent, because it's defined for all real numbers, and its range would be negative pi halves to pi halves, but not including. You cannot include those because tangent y, tangent is not defined in those values. So if this is true, then the tangent, arctangent of x is x, and the arctangent of tangent y, when y is in here, is y. Good deal. Remember those. Now, those inverse properties do not apply for arbitrary values of x and y. In other words, if you're not in that domain or within that range, you can't put the values in there. You can take the sign of an inverse of a 3 halves pi, because sine, the domain of sine is all real numbers, right? So you certainly can do this, okay? But where is 3 halves pi? Okay, you start here. That's pi halves, pi, 3 halves pi. Okay? That's it. 3 halves pi is outside the 1-to-1 domain. So you can't go there. You can take the sign of this, but when you take the arc sign of your answer for that, it's going to throw you back in between minus pi halves and pi halves. It can't reach out there. It can't get there. Because the sign of 3 halves pi is -1, but the arc sign of -1 is negative pi halves. The negative pi halves is not equal to 3 halves pi. They have the same sine function, but they are not the same angles. So that's the key here. In other words, the property arc sine of sine y equal to y only works within this range of y's. Only. It can't include that one. Okay? So the general property for inverse functions only works within the designated domains. Okay? So here's example 5. If possible, find the exact values. Okay? The tangent of the arctangent. Well, what is the arctangent of -5? Can you do that? Answer me that question first. Can you even do that? Can you take the arctangent of -5? Why? It goes from negative infinity to positive infinity. Okay? So yeah, -5's in there. And when you take the arctangent of that, now it says find the exact value. Okay, what would that be? Oh my goodness, wait. That's the arctangent of -5? Okay, then take the tangent of that. -5, you're absolutely right. If you're within that domain, then this undoes that and your answer is -5. You didn't have to punch your calculator to get there, right? Okay. How about the next one? What is the arc sine of the sine of pi, 5 pi thirds, 5 thirds pi? Anyone want to tell me what the sine of 5 thirds pi is? One third pi, 2 thirds pi, 3 thirds pi, 4 thirds pi, 5 thirds pi. Did you say degree?
No, you're looking for like
A number. Because you see, this is an angle. And we take the sine of an angle, you get a number. Sine is the y value. My picture isn't too good, but anyone want to hazard a guess? No one wants to hazard a guess. A little louder. Any guesses? What's that? A little louder. Okay. Okay, what we're looking for is the sine of 5/3 pi. And I figured out where approximately it is. There's 1/3 pi, 2/3 pi, 3/3 pi, 4/3 pi, 5/3 pi. Really is a little more down here, but yeah. Huh? Say it again. That would be like pi. 2 pi over 2 is pi. Right. Say again? Okay. Okay. Now, what both of you seem to be giving me is an angle answer. And what I'm asking for is the sine of that angle. It should just be a number. Oh. What number should that be? It's one of our favorites. All right, -√3/2. The book comes to the rescue. Oh, your notes came to the rescue. Okay, very good. All right. Now, what happens if you take the arc sine of that number? What you reckon you're going to get? Really? What's the domain of, or what's the range of an arc sine? Say again? That's the domain of the arc sine. Negative pi halves to pi halves, and you think 5/3 pi is in that range? No. It's right in front of you on the board. Okay. When I drew these lines here, huh? Okay. We said, here's where you are, Waldo, right? Well, within the domain of this, where are you? What is the domain of arc sine? Negative pi halves to pi halves. So give me an angle, and it's in that. Did you finish? You did. Thank you. Okay. What you gave me here was this value right here, the y value, which is sine of, it's the y value of this right here. Okay? Now, the question is, the arc sine of that y value there would be the angle that's between here and here that has that as a y value. What angle do you reckon this is? Between negative pi halves and pi halves. What angle would that be? Same line. Okay. This is 5/3 pi. That's outside the domain or range of that, right? So what is inside that has the same value? Okay. This was pi thirds, 2/3 pi, 3/3 pi, 4/3 pi, 5/3 pi. What is this angle here? Which way are you going from the horizontal x-axis? Okay, clockwise. So that means the angle is negative. And how far is that? 1/3 of a pi, exactly. That's your answer. Pi thirds, negative pi thirds. Right? Oh, you said it? Say it louder, I can't hear, okay? You did say that? Way to go. Okay. Can you see why? Because it's the same line. This angle here is the same, has the same terminal side as this one. This one's in the domain of this. This one here is not in the domain of that. So it's negative 5/3. Very good. Okay, how about that next one? The cosine of the inverse cosine of pi. Not defining why. Because inverse cosine has a domain of, and is pi within that domain? No, it isn't. Nowhere close. That's 3.14. It's outside -1 to 1. You can't do it. You cannot even do the first part there, much less the second part. Okay. Very good. Does everybody see that? All right. Okay. Let's see how they do these. First, because -5 does lie within the domain of arctangent function, then you just do the tangent of the inverse, and if it's in the domain, it's just whatever you started with, -5, without calculating a thing. You know that. Okay. The second one, though, in this case, the 5/3 pi does not lie in the range of arcsine function, which is -pi halves to pi halves, but what equivalent angle does, and that would be -pi3. Just subtract 2 pi from that, and you get -pi3, and there you have your answer. Okay? And that would be -pi3. Okay? Now, they do it a strange way to get there, but it's still true. And then finally, the expression cosine of inverse cosine of pi is not defined because inverse cosine of pi is not defined because the domain of inverse cosine is -1 to 1, and pi is outside of that. So remember, the domain of inverse cosine is -1 to 1. Okay, that was example 5. They don't do example 6 or 7, so let's us do that. Okay. Example 6. Find the exact value of the tangent of the arc cosine of 2/3. How are you going to do that? Okay, first question. Is this defined? What is the domain of arc cosine? -1 to 1. Is 2/3 within that? Sure. Okay, so we can do it. How do we do it? How do we do that? You know how I would do it?
How would you do it?
Okay, I think I would draw a picture. Aren't pictures worth thousands of words? Sure. Okay, let's draw a circle. Okay? But it's not going to just be any old circle. It's going to be a, let's see, think of this. Let's just call this a variable. You want to name it a variable? Yes, you do. Okay? Give me a variable. Name a variable. X. Okay. So we're going to say arc cosine of 2/3 is equal to x. We already decided it does have an answer, so we'll say that. Rewrite that equation to an equivalent equation, but not using inverse, using the actual trig functions. What would that be? Cosine of x is equal to 2/3. Everybody agree with that? All right. You're easy. Now, tell me, how do we define cosine? How do we define cosine? Say again? Adjacent over hypotenuse. Okay, if we use x, y, and r, what would that be? Okay. Okay. This is not a unit circle, it's a 3 circle. Okay, I just made that up. Okay. Now, I'm going to pick that point right there. Okay. Now, if this is your angle X, right? What is your adjacent side in terms of X, Y, and R? The cosine is X over R. Excellent. Now, I drew a circle of radius 3. That's R equal 3, right? And that made the X here equal to 2, right? Okay. Now, I've got a problem here because you named the variable X, but we're using the X-axis. So let's not name the variable X. Let's name it something else other than X, Y, or R. So give me some other value. It's some other variable. I should have objected before, but I didn't. Some other letter besides X, Y, or R. T? Okay, T for 2. Okay, this will be T here. All right. Whoops, messed it up there too. Okay. Now, all right. Have I represented T well then? I've got an X value of 2 and a radius here of 3. Wouldn't you say that's a fair representation? Okay. Now, so we know this is going to be tangent of that same angle T, because this was T. So tangent of that angle T is equal to what? Can you give me what tangent is in terms of X, Y, and R? The answer is yes, I can. Okay, what is it? Okay. Y over X, excellent. Y over X. We already know what the X is, we just don't know what the Y is. Can you get it, Y? The answer is sure. Okay, what is it? Yes, you do. Huh? Root 5. That's the highway I live. No, okay. That's equal to root 5. How did you get that? In the book? Oh, cheating. Okay. It's the hypotenuse squared minus this side squared.
And then you gotta root it.
Yeah. Okay. Yay! Okay, never mind. Okay. That would be. Oh, you got it. Okay. Okay. That would be the square root of 9 minus 4, which is square root of 5. Okay. So you know what Y is now. So what is tangent T? Root 5 over 2. Do you see why? Sure. Okay, right. No, really, do you see it? Okay. That was too quick. Huh?
You say?
All right. That was example 6A. Let's do 6B. Okay? So how much can I erase or not erase? No, let's erase it all. Start from scratch. Okay. What we're looking for now is the cosine of the arc sine of negative 3/5. All right. Now, before we begin, can you even do this? They put that in parentheses. Okay. What is the domain of arc sine? Negative 1 to 1, is that inside it? Yes, so we can do it. So how would you do it? How would you do that? Second? Okay, but first we have to assign a value to it. What would you want that to be? U? Okay, I like U. Okay, okay. Now, so we have arc sine of negative 3/5 is equal to U. Okay? Rewrite that as an equivalent equation. The sine of U is equal to negative 3/5. Okay, what would you do now? Draw a picture, I like it. And what kind of circle do we have here? What size of circle? What is sine defined as being? Say again? Okay, that's the range of sine. We've already covered that. Yes, it's which? Really? Sine is adjacent? Second. Opposite over hypotenuse. Some old hen, remember? Okay. But what's that in terms of x, y, and r? Well, that's where you were turning the first time. Okay. Get to know these things, folks. This is important. It makes taking the test a piece of cake, you know. And we like cake, okay? Y'all don't remember what sine is? You finally got out. It was hypotenuse. It was a opposite over hypotenuse. Some old hen. Your opposite side is always your y side. Y over r, very good. Okay, so y over r. Now I've got a minus sign there. Where does the minus sign go with? The y or the r? The radius is never negative. Ever. And with the y, okay. So we're going to do a 5 circle, radius of 5. Okay, there's my 5 circle. And my y value is negative 3 over r. This is the angle T that we're dealing with. This is interesting, isn't it? So technically, this is the U we're dealing with here. Or we could be dealing with that U, either one. Okay? Now, that's whose sine is negative 3 over 5. Okay. But we're wanting to take the cosine of that angle, U. Can we do that? Okay, what is the cosine of that angle? What is cosine? Say again? I can't hear you. Adjacent over hypotenuse in terms of x, y, and r, what is that? X over r, exactly. Okay, so the cosine of u is x over r. What is our x here? We know the y is negative 3. The r is 5. What is the x? 4! You're absolutely... Did you read it off the thing? Actually, 5 squared minus 9. 25 minus 9, 16 is 4. Positive 4, right? There it is, positive 4. So this is 4 over 5. There's your answer. And that's exactly what we got here. The first one was root 5 over 2. I forgot to check it in the book, but it did give me that. All right, unfortunately, I thought for sure we're going to finish this section today. We didn't quite, but came pretty close. So we'll pick up here with Example 7 next time. It's not on the slide set. So, but homework exercises. Do any of the odds 5 through 17. Do 19. Do any of the odds 21 to 37. Do 39. Do any of the odds 41 to 45. Any of the odds 47 to 51. Any of the odds 53 to 63. Any of the odds 65 to 73. Do 75. Do either 77 or 79 or both. Do 81. Do any of the odds 83 to 87. Do any of the odds 89 to 93. Do 95. And try to do some of the odds 97 to 102. Okay? And I'll assign the rest of those later. Okay, good deal. Have a good weekend. Get me some stuff in Tuesday if possible. Okay? Good deal. Have a good weekend. See you Tuesday.